So I guess we are online.
Welcome. So I'm Elizabeth, and I'll be guiding you through today's webinar. We are excited to continue our webinar series with a session on modernizing application front ends. In this series, we look at real engineering challenges and practical ways that teams work with cloud technologies. Our speaker today is Andriy Sayenko, a senior software engineer with over 9 years of experience. He's an Azure certified engineer with strong expertise in Angular and TypeScript, and a solid background in building scalable, maintainable front-end systems. Today, Andrei will share how to evaluate an existing front-end application and choose the right approach to modernization using real-world examples and proven architectural patterns. So let's get started. Over to you, Andrei.
Okay, hi everyone. As Lisa said, I'm a software engineer with experience of over 9 years. Started as a simple HTML and CSS markup developer. Made my way through JS, Angular JS, worked with different libraries and frameworks, as a little bit with React, Vue.js, but mainly uh, my main stack, my main technology is Angular and all related components, features, and etc. So today we are going to talk about the how we can modernize and upgrade our legacy project, or maybe not so legacy, but still keep our project updated, last version and last trends. So here how we will structure our time today. We'll dedicate a full section to each strategy, starting with refactor, then replatform, and after that we will talk about rearchitect. For each one, we'll cover what it means, when to use it, and the most common real-world scenarios where it applies. We'll close with the comparison table and the practical decision guide to help you choose the right approach for your specific situation. And feel free to ask questions at the end of this presentation. I will be glad to answer them. So let's start with refactoring. It's almost always the first step, regardless of what else need to happen to the application. Before you move infrastructure or redesign the architecture, you want your code base to be clean and understandable. Otherwise, you carry the mess with you into the new environment. And think of it like tidying a room before you move house. It's easier to pack, move, and unpack a tidy room. So, the formal definition of refactoring comes from Martin Fowler, improving the internal structure of code without changing its observable behavior. No new features, no bug fixes, just making the existing code cleaner, faster to read, and easier to maintain. In Angular specifically, refactoring tends to surface in a few recognizable ways. Components are too large, rig.js subscriptions are leaking, change detection is running more often than it needs to, or the code base has drifted away from current Angular ideals. The key characteristic in the panel on the right are important to communicate to stakeholders. Refactoring is low risk, low cost, and produces no behavior changes. That makes it the easiest sell to this tree among all these three strategies. So let's take a look on these six tasks, which represent the most impactful refactoring moves in a typical Angular project. And let me walk through each one briefly. Component decomposition is usually where you start. Large components are hard to test and impossible to reuse. Breaking them down pays dividendly immediately. And the next step is a rigs.js cleanup, which is critical for performance and memory safety. Nested subscribes are one of the most common sources of memory leak in Angular apps. And I remember the situation when I had in my project like 6 nested subscribes, and it was like some cascade hell. for maintaining, understanding, and etc. And we will have the example how we can solve this problem. Okay, the next one is on push change detection strategy. It's the quick win that can dramatically reduce render cycles and often cutting the CPU usage in half for data-heavy UIs. Standalone components are the future of Angular component model. Migrating away from ng models reduces boilerplate and make the code base easier to reason about. The next step is lazy loading, which is often the fastest way to improve initially load time, splitting routes into separate chunks so only what the user needs gets downloaded upfront. Strong typing catches entire categories of bugs at compile time. Removing any is tedious but pays off every time. TypeScript saves you from a runtime error. One of the great things about the Angular ecosystem is that many refactoring tasks can be automated. And let's take a look how we can do this. Angular CLI schematics are the backbone. ng-update command not only bumps version, but runs migration scripts that automatically update deprecated APIs in your code, and this is the huge for major version upgrades. ESLint, with the Angular-specific rule set, will flag deprecated patterns, enforces and consistent code style, and even auto-fix many issues with like hyphen fix prefix. Angular DevTools is underused by most teams. To be honest, I also briefly use it, but still uh, it's some way to improve in Angular project. So the component tree inspector and change detection profiler can immediately show you which components are re-rendering unnecessarily. NXJS is worth mentioning even if your project isn't in a monorepo yet. Its dependency graph and affected build analysis can tell you exactly what is impacted by a change and which is invaluable before a large refactor. And now let's take a look on some examples of refactoring, which you can use in your project. So here is the example of component decomposition. On the left, we have a classic GUT component. It's over 300 lines, handling HTTP, state, and three separate UI concerns, all in one place. And notice that the any types everywhere and the flat procedural structure uh, which we can see on this example. There is no way to test the delete logic without also rendering the entire form. For example, we see several functions like delete, edit, and etc. On the right hand, we have the smart component, which is just 15 lines. It knows about data, selecting from the facade and dispatching actions, but has no HTML opinions. The dump user card component handles the rendering and emits events upward. Now you can unit test the card with simple input mocks and completely isolate from the HTTP layer. Next example, it's about Eric's JS cleanup, which I mentioned before. On the left hand, we have a callbacks pyramid, three nested subscribes calls. The outer subscription listen to the route parameters, and the middle one fetches the user, and the inner one fetches the orders depending on the user ID. Every level adds indentation and increase the risk of forgetting to unsubscribe. And if the user navigates away mid-request, you have a memory leak and potentially stale data. On the right hand, we replace all of that with a single declarative pipe chain using switch map. And the key benefit of switch map is that when a new value arrives, a new route parameter, for example, it automatically cancels the previous inner observable. No leaked request, and take until destroy from Angular 16 eliminates the need for ng on destroy entirely. So it looks much cleaner and much simpler. And the sync pipe in the template handles subscription management automatically. So let's move to the next section of our presentation. It's about replatform. Where refactoring was about the quality of the code, replatforming is about the environment the code runs in, and the application logic stays largely intact. What changes is where it lives and how it gets deployed. Mostly, it's the task not from the simple front-end developer, but mostly for DevOps. So usually in big teams, you shouldn't worry about, but it's good to know how it works and how you can improve your project, for example, maybe pet project by yourself. A useful way to think about it, if refactoring is tied in your room, replatforming is moving to a better apartment. Same furniture, but better location. Replatforming addresses infrastructure problems, not code problems. The question you're asking is our current hosting deployment pipelines or rendering strategy holding us back? If the answer is yes, and it often is for teams that have been running for several years, for example, replatforming is the right move for you. Common signals for replatforming is when deployment is manual or error-prone process, and the app has no server-side rendering, or, for example, SEO is suffering in such cases, or the team is paying for infrastructure that doesn't scale efficiently. Notice the characteristics, medium risk and the medium cost. More involved than refactoring from the previous section, but still well contained because you're not rewriting business logic in such case. And let's take a look of some common scenarios. For example, moving to a managed hosting provider, Vercel, Netlify, or Azure Static Web Apps is often a weekend project that eliminates an entire category of DevOps burden. And these platforms handle CDNs, HTTPS, preview deployment, and rollback put out of the box. The next step, containerizing with Docker and GNX, which gives you deployment consistency. The app runs the same way in development, staging, and production in your case. Adding a server-side rendering via Angular Universal or the built-in server-side rendering in Angular 17 and later versions is one of the highest impact replatform moves for apps that need good SEO or fast first contentful paint. The next one is static site generation, which is the right choice for content-heavy pages that don't change per user. Pre-rendered HTML is the fastest possible delivery. The next one is modernizing CI/CD, moving, for example, from Jenkins to GitHub Actions or some other way of CI/CD, for example, maybe Azure pipelines, can cut feedback loops from 20 minutes to 3 minutes and dramatically improve the developer experience. And finally, Adopting to NX as a mono-repl platform adds powerful tooling without requiring you to touch any business logic. Let's take a look on some key considerations. For example, built-up compatibility, different hosting platforms expect your files to be structured differently. Always test that the dist folder or output folder works on the new platform before cutting over. Environment variables handling is a frequent source of bugs. In Angular, you're likely used to environment TS file, but most cloud platforms inject secrets differently. And make sure you have a runtime config strategy for such cases. The single-page application routing fallback is the classic gotcha. If you navigate directly to, for example, some product page with ID 123 or some other ID in the browser, and the server doesn't know to serve index.html, you get a 404 error. And every platform configures this differently, and forgetting it's embarrassing to explain to stakeholders. Bundle optimization is worth revisiting when you replatform. New infrastructure often brings new opportunities, enabling, for example, broadly compression or configuring long-term caching headers or using a CDN closer to your users. So it can be the good move to improve uh, your performance during the replatform. And let's take a look on some examples uh, how we can improve our project. For example, uh, here we have workflow replaces a Jenkins pipeline that might take 20 and more minutes, as I mentioned before, with the fast parallelizable GitHub actions that run typically completes in 3-5 minutes approximately. Key things to notice that the cache npm option on the node setup step caches the node modules between runs and dramatically speeding up the subsequent builds. The step runs sequentially and lean first the fastest feedback, and then test, and then production build. The deploy steps sync the build dist folder directly to an S3 bucket with the delete flag, so stale files are removed. And CloudFront invalidation ensures the CDN serves the new files immediately rather than waiting for cache expiry. And the AWS credentials are stored as a GitHub repository secrets. They never appears in the workflow files itself. The next one example, it's about the server-side rendering. On the left, we can see it's just one command to add server-side rendering to existing project. It's ng at Angular server-side rendering, Angular SSR, sorry, yeah. And the Angular JSON configuration shows the key SSR options, the browser and the server entry point, pre-render with the flag true, which pre-generates HTML for non-static rows and build time, and the SSR dot entry pointing to server TS file. On the right is the auto-generated express server file, and the common engine is Angular server-side rendering engine, which we can see on the screen. And it takes the bootstrap function and the URL and returns fully rendered HTML, complete with SEO-friendly meta tags, accurate first paint content, and no need to wait for JavaScript to bootstrap before the user see anything. And the last section of our presentation, it's about Rearchitect. If refactoring is cleaning your room and replatforming is moving to the better apartment, Rearchitect is like knocking down walls and rebuilding the floor plan. This is where you make structural decisions that will affect how your team work for years, how state flows through the application, how features are organized, how I don't know, teams can work independently without stepping on each other, and etc. So rearchitecting is appropriate when the fundamental structure of the application is what's holding you back, not the quality of the individual components or the hosting environment. The most telling signal is when uh, multiple developers are constantly merging conflicts in the same files, for example, during the pull requests, or when a bug is some bug fix in one feature breaks some functionality in some other component, some other feature. These are the symptoms of poor architectural boundaries. And another strong signal, if your team has grown to, for example, 5 or more engineers, and everyone is working in the same feature area, and you've likely outgrown a monolith Angular application and need to think about other of, I don't know, DDLR structure or micro frontends, for example. And here we have some 6 common scenarios. Or actually, we have more of them, but uh, these 6 are the most like uh, most meeting in the Angular projects. So introducing NX, NGRX, or equivalent state management library, for example, maybe Signal Store, which provides the last versions of Angular. It brings predictability to application where state has become scattered across dozens of services, and their Redux pattern combined with DevTools makes state changes fully traceable and debuggable. So you can use any state management which is applicable to your application. Moving to Angular signals is the most forward-looking change on this list, I would say. Signals are Angular's new reactivity primitive, and they significantly simplify reactive code compared to RxJS for many use cases. The next one is micro frontends. It's not highly spread practice, but still it's very powerful for big scaling applications. And micro frontends via model federation is the right call when you have multiple teams that need to deploy independently. For example, some different feature or different areas of your application. And each team owns a shell or feature area that can be released without touching the others. The next one is domain-driven design, reorganizes code by business capability rather than technical role. Instead of a flat service, for example, with the services folder, you get the feature, which splits. For example, you have a feature, user feature, or some orders feature, or uh, some notification feature, or etc. Each folder will be with its own components, services, models, store files, for example, for caching some state. A shared design system ensures visual consistency and eliminates duplicated UI logic across the features. This often has a dramatic impact on development speed. And finally, the facade pattern, which creates a clean, contract between your UI components and the data layer. Components become much simpler and easier to test. And here's some key architectural patterns. Let's zoom in and check what we have here. The facade pattern is arguably the most impactful single pattern you can introduce. Facade services exposes simple, purpose-built method to components, hiding all the NGRX selectors, dispatchers, and HTTP calls behind the clean interface. Components become thin and testable, as I mentioned before. The feature shell UI data access layering model popularized by the NX team provides explicit rules about which layer can depend on which. And features can use UI and data access libs, but UI libs cannot depend on features. These constraints prevent architectural drift. Event-driven communication using NGRX actions or custom component bus decouples features from each other. For example, instead of feature A calling to method in feature B service, it dispatches an event that feature B happens to respond to. The sender doesn't need to know who is listening. And finally, the concept of smart dump components are the foundational pattern that makes everything else work. Smart components own data and orchestrate behavior, and dump components just render the props. Dumps components become like maximally reusable and trivially testable. And let's check on example. In this example, we have two different way of structure. The old one, when Angular just started its own way, and more modern approach for the structure for Angular component. But I think that it can be applicable for some other projects on maybe React.js and Vue.js. So this structure is like much cleaner from those approaches which we had before. So on the left, we have the traditional Angular structure, groups all components together or services together, all models together. And when you make a change to the orders domain, for example, let's say adding some field, for example, in the model, in the form, you have to touch four separate folders. You should make some changes in the component, some changes in the services, in the models, just upgrade some properties in the model, and etc. And also update the model in the store, so it can be messy. On the right hand, we have each domain library like is self-contained. We have feature users, feature orders, and each feature has its own set of folders, components, services, models, store, and etc. And just keep your attention on the index TS file. It's like critical for such structure. It defines the public API of the library, and other domains can only import what's exported from the index TS file. And internal implementation details are invisible and protected from unintended coupling. In NX, this boundary enforcement is automatic. If you try to import from inside lib's source folder instead of through the index.ts barrel, the init least command will fail, and architecture becomes something like the tool enforces not just a convention people hope to follow. And here is the comparison summary of all these three components: Refactoring, Replatform, and Rearchitect. Uh, this table is the single most useful reference for communicating these strategies to stakeholders and engineering leads. The color coding tells the story at a glance. Green is safe and cheap. Yellow requires planning and budget, and the red requires executive buy-in and careful risk management. The key insight is the diagonal progression. As you move from refactor to replatform and to rearchitect, every dimension escalates: risk, cost, duration, and potential behavior change all increase. This is why the other, sorry, not the other, like order in this case matters a lot. You don't start with re-architecting. You refactor first to clean the foundation. After that, you replatform when infrastructure becomes the constraint, and the architect when scale demands it. And in practice, real project needs all these components. It's not like the option when you choose between refactor, replatform, or rearchitect. Usually, like in the best cases, let's say, you use all these three strategies to maintain your project up to date and the last version to make your life much easier for the further development. And this slide is your practical cheat sheet. Use it to diagnose which strategy applies to your current situation. If code quality is the problem, messy, untestable, hard to navigate, start with the refactor. It's always the right first move and the lowest risk entry point. If infrastructure is the bottleneck, just slow deployment or poor CO or expensive hosting. So your choice is replatform. The code doesn't need to change, the environment does. If structural boundaries are broken, teams conflicting, state unpredictable, or features coupled, so in this case, you should re-architect. This requires a longer timeline, and the team alignment is the only way to sustainably scale. Notice that the signal in each column are very, very specific. Deployment takes more than 20 minutes. It's the replatform signal and not a refactor signal. State box appears in unrelated features. It's rearchitect signal, not a replatform signal. And you should train your team and train yourself to recognize these patterns early. And let's close up. Let's bring it all together. Refactor, it's the clean way you have, clean what you have. This is ongoing, continuous work, not a one-time project. You should add some time for refactoring every sprint, at least a couple of hours. It will be more than enough for each sprint. Replatform, move where it runs. Do this when your infrastructure is the constraint, and do it as a focused, time-boxed effort. Re-architect, redesign how it's built. This is the strategic planned work and requires alignment across the engineering, product, and leadership. The most important takeaway, these are the tools, not the destination. The goal isn't to finish re-architecting. The goal is to keep your application healthy enough to ship value confidently and at whatever scale you're operating at. and pick the right lever for the right problem. Thank you for your attention, and I will be pleased to answer your questions.
Okay, thank you, Andrei.
You're welcome.
Let's wait for the questions. Yeah, so this is the perfect
Okay.
time now to send your questions. Okay, I think we already have some questions in our Q&A. So Andrei, over to you again.
Sorry, but I don't see any. Oh, yeah. Now I see. Okay, let's start. When exactly should we stop refactoring and jump to rearchitecting? Where is the line? I think that you should go step by step for uh, on each of those instructions which I gave you. And when you don't see any uh, most impactful way to improve your code, so in that case, you should go jump to the next step of actually not rearchitecting, but replatforming. Rearchitecting is like the last step in this chain of project improvement. But still, yeah, after refactoring, especially if the replatforming is not your responsibility, it's a responsibility of mostly the DevOps team. You can jump to Rearchitect and check what you can improve to um, make your services, components, and etc. standalone. And if uh, your team works on the different bugs or tasks in the one feature, it's the signal that you should split that feature in some smaller components to avoid some overstepping on each other during the merging your code into the pull requests. So the next question: how do we convince management to invest time in refactoring when it doesn't ship any new features? Oh, yeah, that's the good question. You should sell this solution to your management as, uh, let's say, the business likes to uh, think every values in the money equivalent. And you can sell this solution as the saving their money because, for example, good structured and well-structured features, uh, which was refactored previously, will save the development time in the future in implementing new features. So if you save some time during the development, it reduces the cost on the development, obviously. So you can sell this idea like that. So it will reduce their costs during the development in future. So okay, micro frontend sounds great, but isn't the overhead, separate deployments, shared dependency management, cross-team coordination often worse than the problem they solve? Yeah, that's the good question. For example, I think that, for example, some small application, it uh, some small application don't need it, don't need it at all because it will be like overdevelopment. But for some big project with a lot of different business logic models, different features, it will be the good choice because, for example, you have a large project with different features. For example, orders, some buckets, some user model, and etc. And for each model, you have its own team. For example, 2, 3 developers for each. And all these teams deliver some features frequently or from time to time, and you need to deploy these features, but it will make the deployment chaos. And in such cases, some micro frontends will help you because each feature will be deployed separately and will not touch any other features, any other deployments. So it will deploy, for example, if we have some changes in user model, we will deploy only the user module, and it will not touch some order parts or bucket parts or some others. So they will stay safe and functional for users or testers for business. Thanks for the presentation. I've heard an opinion recently that as AI tools become more effective, the need for refactoring and maintaining good code structure may be reduced since the developers will be able to use those tools to manage the code base. Do you agree with that? Yeah, that's the good one. And according to nowadays tendencies of AI, I think it's a little bit too early to leave this task only for AI. If you do this, you should check everything which your AI agent uh, provides you after his actions of some structure changes on etc. So you can use it, but uh, personally, I would not. If I would use it, I would check it twice or thrice times after my UI, oh, sorry, AI agent. But still, I think it improves so quickly that, for example, at the end of this year, maybe I'll change my mind, and we all can like relate this task on the AI agent. Not 100%, but maybe 90%, and just check briefly the main key points uh, of the code structure. So let's check once again if we have some new questions.
Yeah, I think these are all the questions for now.
Yeah, thank you guys for these questions because it's really relates to nowadays development, and it's like the key points of all our work, which we meet maybe not every day, but from sprint to sprint. So yeah, thank you.
Yeah, thank you. Thank you to our participants for all the questions. And also a big thank you to you, Andrei, our speaker, for practical insights into scaling modern applications. You're having the applause that are completely deserved. And we hope this session gave you a clearer picture of what modernizing legacy front ends look like in real projects. From architectural choices to real-world trade-offs and Azure-based solutions. If you have any follow-up questions or would like to talk about your own challenges, feel free to reach out to the CIGN team. and we're happy to offer a free consultation to discuss next steps. We'll be continuing this webinar series, so if there are any topics that you'd like us to cover in the future around Azure, AI, or application modernization, we'd love to hear your ideas. And thank you again for joining us, and we hope to see you at the next session. And have a nice day, everybody. And goodbye.
Yeah, thank you guys. Have a good one.
Bye.
See you. Bye.